video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, today in our third part of properties of inverse trigonometric functions, we will be proving three more similar properties. So our first property in this part is cos inverse minus x is equal to pi minus cos inverse x. So to prove this, let cos inverse minus x is equal to y, or y is equals to cos inverse minus x. Now take cos both sides. Then cos inverse minus x will be minus x, because cos inverse theta is theta. So cos y is equal to minus x, or minus cos y is equals to x. Now cos is positive in first and fourth quadrant, whereas it is negative in second and third quadrant. So in second quadrant, theta is 180 minus theta or 90 plus theta, but here we will take 180 minus theta. So cos 180 minus theta will be minus cos theta. So minus cos y can be written as cos 180 or pi minus y. So cos pi minus y is equals to x. Now take cos inverse both the sides. So cos inverse cos pi minus y will be pi minus y, because cos inverse cos theta is theta. So pi minus y is equal to cos inverse x. Now substitute the value of y, which is cos inverse minus x. So pi minus cos inverse minus x is equal to cos inverse x, or cos inverse minus x is equal to pi minus cos inverse x. So this is how we prove this property. Now a second property is sec inverse minus x is equal to pi minus sec inverse x. So to prove this, let sec inverse minus x is equals to y, or y is equals to sec inverse minus x. Now take sec both the sides. So sec inverse minus x will be minus x, because sec inverse theta is theta. So sec y is equals to minus x, or minus sec y is equals to x. Now sec is positive in first and fourth quadrant, and it is negative in second and third. So in second quadrant, theta will be pi minus theta. So sec pi minus theta will be minus sec theta. So for minus sec y, we can write sec pi minus y is equal to x. Now take sec inverse both the sides. So sec inverse sec pi minus y will be pi minus y, because sec inverse sec theta is theta. So pi minus y is equal to sec inverse x. Now put the value of y, which is sec inverse minus x. So pi minus sec inverse minus x is equal to sec inverse x, or sec inverse minus x is equal to pi minus sec inverse x. So this is our second property. Similarly, we can prove our third property, that is cot inverse minus x is equal to pi minus cot inverse x. And to prove this, let cot inverse minus x is equals to y, or y is equals to cot inverse minus x. Now take cot both sides. Then cot inverse minus x will be minus x, because cot inverse theta is theta. So minus cot y is equals to x. Now cot is positive in first and third quadrant and it is negative in second and fourth. And in second quadrant, theta is pi minus theta. So cot pi minus theta will be minus cot theta. So for minus cot y, we can write cot pi minus y is equals to x. Now take cot inverse both sides. So cot inverse cot pi minus y will be pi minus y because cot inverse cot theta is theta. So pi minus y is equal cot inverse x. Now put the value of y here and the value of y is cot inverse minus x. So pi minus cot inverse minus x is equal to cot inverse x, or cot inverse minus x is equal to pi minus cot inverse x. So this is our third property. So in our previous videos in part 1, we proved these three properties. In part 2, we proved these three properties. And in this video, in part 3, we proved these three properties.